The topic that will be discussed in this video is compound events. Compound events consist of two or more events. The first one we're going to talk about is independent events. These are an occurrence of one event does not affect the probability of the occurrence of the other. For example, we're going to roll two number cubes. We're going to use that the probability of A then B equals the probability of A times the probability of B. Our first example would be the probability of a 1 then a 2. What that means is that I am going to get a 1 on one of these and a 2 on the other. So what we have to do is we have to find the probabilities of them separately. So first I'm going to find the probability of a 1. We know that there is 1 on the number cube, which we'll put 1 on top, and 6 total on the bottom, so it would be 1 out of 6. Same thing about the 2. We would then find the probability of a 2 on the number cube. So we have one option of a 2 happening with 6 total options. And then we would multiply those. 1 out of 6 times 1 out of 6, multiply straight across, gets me 1 out of 36. Another example would be the probability of an even, then a 5. If we separate that, find the probability of an even on the first number cube. We know there are 3 evens on a number cube with 6 possible, giving you 3 out of 6. We're going to simplify first to give me 1 over 2. I'm then going to multiply that by the probability of getting a 5 on the second cube. We've got 1 5 with 6 total, giving me 1 out of 6. Multiply straight across, getting me 1 out of 12. So the probability of rolling an even number on the first die and a 5 on the second is 1 out of 12. So those were both independent events. The 2 die did not affect each other. Now let's take a look at dependent events. So dependent events are events where the second one affects the first. So we're going to imagine that we have these color blocks in a bag that I'm going to ask people to draw out of. We're going to use the same concept. The probability of A then B is the probability of A times the probability of B after A happened. So as you can see, there are 10 blocks on this right now. We're first going to ask for the probability of a red then a green. The probability of red is just like the number cube. There are 2 reds with 10 possibilities, which I simplify to 1/5. However, the green is a little bit different because if I've already drawn 1 out, let's pretend I drew the red out, I now only have 9 blocks to draw from. So the probability of a green is 3 out of 9, which we simplify to 1/3. Do just like we did before, multiply straight across. The probability of a red then a green happening is 1 out of 15. Let's try another example. The probability of a blue then a blue. So again, we're going to start with all 10 number blocks in our patch to draw from. The probability of a blue, you'll count 5 blues out of 10, simplifies to 1/2. Now, if I pretend I drew a blue on the first one, as I'm assuming I did because that's what I'm asking for, I now am left with only 4 blues and 9 total blocks. So I've got 4 out of 9. Multiply straight across, 4 out of 18. Again, I'm going to simplify and get 2 out of 9. So the probability of drawing a blue, then another blue, is 2 out of 9.